During your pre-flight planning, figuring out where to fly so you avoid thunderstorms is a pretty important consideration. You've seen how they report or forecast thunderstorms in the METAR and TAF. And believe me, the very mention of thunderstorms cranks my decision-making process into high gear. So I want to look at anything that helps me know where thunderstorms are and what they're doing. And one of those sources is radar. You see, radar can detect thunderstorms as well as general areas of precipitation. Once each hour, most radar stations issue reports of radar echoes by direction and distance from a particular station. Now, the report will give you the type of precipitation, the intensity of it, the intensity trend, and its location. That report is called the Radar Weather Report, or SD. For instance, this is a radar weather report for Oklahoma City, OKC. Now, it says that at 1934 Zulu, there was a line of 8/10 coverage of T, which stands for thunderstorms, and RW, rain showers, and the two plus signs there indicate very heavy. Some other symbols that you might see there for intensity are a single plus, meaning heavy, or a minus for light intensity. And if you see no symbol there, it means moderate. The symbol after the slash here indicates if the weather is increasing or decreasing in intensity. A plus sign like this means that it's increasing. A minus sign would mean it's decreasing. If there were an NC here, it would not mean no charge for the burgers and coffee they serve at the airport restaurant. It would mean that there was no change in the intensity. So in this case, you find thunderstorms with very heavy rain showers, and the intensity is increasing. I think I'll stay in the restaurant. Now, how do we define that line of thunderstorms? Well, you'd find the first point in it if you went out on a true heading of 086 degrees for 40 nautical miles from the station. Then you'd go out 164 degrees for 60 nautical miles to find the second point. And if you went out 199 degrees for 115 nautical miles, you'd find the third point. So let's plot that. The first point is located 86 degrees and 40 nautical miles from the Oklahoma City radar. The second point is located 164 degrees and 60 nautical miles out. And the third point is located 199 degrees and 115 nautical miles out. What you have when you're done are 3 points which you can connect to show a kind of a curving line. That curving line represents where you'll find the line of thunderstorms, or at least where it was at the time of the report. That line is 15 miles wide, or 7.5 miles on either side of that curving line you just drew. That's what, in the radar report, this 15W for 15 miles wide is telling you. Now, this notation tells you that the line is moving from 240 degrees at 25 knots. And you know they're talking about the line moving at that speed because of the L in front here. If it were an individual thunderstorm cell, they'd put a C in front, or put an A if it were an area of thunderstorms. Now let's take a look and find the maximum tops that they've observed. Maximum tops are designated by the abbreviation MT, and the maximum observed tops were 57,000 feet. Now that is a big, big thunder bumper. Where are they located? Those tops were located at 159 degrees from the Oklahoma City station and a distance of 65 nautical miles. By the way, that's the top of the radar echo, not necessarily of all of the clouds. Now, this note tells you that 2-inch hail was reported in this particular cell. In other words, this is definitely something you want to give a very wide berth. So with information from radar weather reports, along with the METAR-TAF reports, you're on your way to getting a good picture of the weather, and especially thunderstorms. and a good picture is about all you ever want to see of them.